Hi everyone, so let's do today's daily LeetCode challenge question. The question is 1861 rotating the box. Okay, so as usual, let's set 20 minutes timer and I'll try to finish until 20 minutes. So it is 7:48 p.m. Okay, so I should start 48, yeah, 18. Okay, so 1861 rotating the box. Let's read the question. You are given an I'm streaming, right? Yeah. You are given an m times n matrix of characters box representing a side view of a box. Each cell of the box is one of the following. Okay, so I will be given m times n matrix, and characters will only be either hash or asterisk or dot. Okay, so asterisk as is a stone and asterisk is an obstacle and dot is empty. So the box is rotated 90 degrees clockwise. Okay, so if this is a box, then if it is rotated 90 degrees, 90 degrees clockwise, so this m times n matrix, it represents side view of the box, right? So um, so if this is a box, then it will, I think we will see this view, and if I rotate it 90 degrees, then what will happen, causing some of the stones to fall due to gravity. Each stone falls down until it lands on an obstacle. Okay, so this will fall and it will land on obstacles. Another stone or at the bottom of the box. Okay, gravity does not affect the obstacle's positions, and the inertia from the box's rotation does not affect the stone's horizontal positions. What does this mean? Inertia from the boxes does not affect. Okay, so stone's horizontal positions will be the same. Okay, it is guaranteed that each stone in box rests on an obstacle, another stone or bottom of the box. Okay, so return n times n matrix representing the box after the rotation described above. Got it. Got it. So I'm trying to visualize here, and I'm not so good at visualization. So so they it so we will be looking at one side of the box, right? One side of the box, and that will be m times n. So suppose this is 7 times 3, then if I'm looking at this side, then it will be 7 times 3, right? But if I rotate this, it will be 3 times 7. Yeah, that's what it's happening. If I look at this, it is 7 times 3, and if I rotate this, it will be 3 times 7. But if I'm looking at this one and the stones, so stones, yeah, so there will be stones. If I look here, then there will be stones, there will be obstacle, and there will be empty cells. Okay, and if I do it this way, then the stones will fall. Stones will fall either to either it will rest on the top of another stone, or top of obstacle, or it will go to the bottom here. Okay, okay, so if I rotate it, so suppose if a stone is here, and if I rotate it, then it will go down. Yeah, that's true. If I rotate it, then it will go down on the 7 column. So what should I do then? Oh my god, why am I taking such a long time to come to the solution? I should come to the solution quickly. Yeah, I should come to the solution quickly. So let's think of the solution then. What can I do? I need to it on n times n matrix representing the box, right? So suppose this is the one, then what will happen? So there is just one row only, so stone is here and this is empty and there is stone here. So if I rotate this, then it will, obviously the stone will so this is a row right now, right? But this will become a column, so it will be like has, no, it will not be has, empty, has and has. Yeah, so this row will be a column. So in the column I need to drop. It is easy, right? So here suppose if this is the box, then this row will be a column if I do 90 degrees. So this will come here, so it will be like, so suppose I'm just converting, okay? I'm just rotating 90 degrees without so what rotating 90 degrees will look like? Just rotating box to 90 degrees. 90 degrees will change my rows to column. It is like will change my rows to columns and columns to rows, right? So if this is my row, then this will be my column, and if this is my column, then this will be my row. Yeah, so it will just be like this. So if this is a column, then asterisk dot and has asterisk dot. Okay, yeah, so this is how it looks like if I rotate it. This is has dot, if I rotate it, then it will be has dot. If there is, I'm just trying to figure out if I rotate it to 90 degrees, then this is how it looks like. If there is has dot here, then if there is has dot here and has here, then there is has dot here and has here. Has. So this second column will be my first row, I think. I think it is opposite actually. I think the second column will be my first row. I'm just trying to find out, by trying to visualize. Say, I think that second column will be, I think the last column will be first row, right? Because if this is my first row right now, this is my first row, then this will be my first row. Or no, oh my god, why am I complicating? I think that I'm complicating too much. Just visualize, leave this button. So yeah, if I rotate something to 90 degree, if this is a row and this is the last row, then it will be my last row will be my first column. Right? My last row will be my first column and my first row will be my last column. Similarly, my first column will be my first column will be my first row, I think. Yeah, I think so. I think this is right. So my last first column will be first row only. So and last column will be the first, last row will be first column. Oh my god. Why am I taking such a long time to know which row will be which column? Obviously, if this is my box, this is my row, right? Length. This is my row. This is my first row. it will be my last column, and my last row will be my first column. And if this is my first row, it will be first row will be, sorry, first column will be first row, because I'm just rotating 90 degrees only. If it is like this, what does rotating 90 degree mean? If it is like this and if I do this, then it is 90 degree. Yeah, it is 90 degree. So yeah, so first row will be, first column will be my first row. So see, this is my first row, and this will be my first, sorry, this is my first column, this will be my first row, and this is my last row, this will be my first column. Oh wow, this is so funny. And what will be my last row then? If my first column, so this is my last column, then it will be my last row. Yeah, last column will be my last row, and first row will be my last column. Yeah. I think that I just instead of thinking about all this, I could just have tried to convert this, and I think that I'm thinking too much. So let's convert this. So if I'm just converting this without thinking about if stones will drop or not, if I just rotate this box to 90 degrees, then this is how it will rotate, right? First row will be last column, so actually first row will be last column, so it will be like this. Yeah, so this is the first row, and this will be this, and second row, this will be this. Last row will be first column and first row, and first column will be first column will be first row. So this is as first row, and last column will be my last row, first. What am I doing here? The first column will be first row. This is my first column, first row. Oh, last column it will be last row, dude. Last column will be last row, yeah. So this is good. And now I need to think about, so how will it look after stones drop. So if stones drop, then it will like, this is hash, right? And this is obstacle. So here there is no any place to drop, and this stones it is only. So here this will drop, this hash will drop here. So it will look like this. It should come here, hash, and this would be empty. So if I see any hash, I need to go down until I yeah, actually I think I should start from the last row. I think that I should start from the last row and then see if there is any stone. So if there is any stone, then I should bring it down. Yeah, I cannot start from the first row, because suppose if this was empty, then if I start from my first row's stone, then I will see that, okay, this is an obstacle, so this will not drop anywhere. So I should always start from the bottom, so that everything will be where it is, and when I reach here, I know that if it is empty or not. So if this is hash, then yeah, is this the answer? Hash asterisk hash dot hash asterisk s. Yeah, this is the answer. Yeah, so I think my approach till now is working. So let's rotate this. So first row will be my first column, right? Oh no, my last row will be my first column. So hash dot hash dot, okay, and it will be hash asterisk dot, and then hash asterisk dot asterisk dot. Actually, when I'm constructing this, what I can do is, So I know that last row will be my first column, right? So maybe I think I can just go from this one, you know. So instead of constructing this, um, instead of constructing this and trying to figure out, so I could just maybe, because I know that this last row will be my first column, right? So I can just go from the end in the beginning. Or you know what, I'm trying to just figure out, okay, suppose, okay, this is the thing. Now I'm trying to figure out how I will, I'm trying to figure out the solution, you know. So for this one, there is a stone here, so this stone will drop here, and there is another stone, so this stone will also drop here. There is another stone, so this stone will also drop here. There is another stone, this will also drop here, right? And this is empty, this is a obstacle, and this is a stone, nothing. This is empty, this is obstacle, this is empty, this is obstacle. So this would be the answer. Dot dot has asterisk dot dot has asterisk dot asterisk has dot. Yeah. So I think what I can do is I can just look from the end, you know. So what I did was, so suppose if this is the column, okay, so let's just think about logic, okay, logic to figure out how the stones drop. So suppose if this is, so how the stones drop in a column, okay. So suppose there is a stone here and this is dot, here there is stone here, there is dot, and there is stone here and dot, stone here and dot. Okay, so what I can do is I can just go from the bottom first, and then I think that I can just last obstacle, you know, last resting place, I can just update, I think, position, you know. So if the last resting place is, suppose this is 0, I'll know, right? And this is hash, so for this hash my resting place will be this. Yeah, so for if I meet any stone, then my stone will go to the last resting place. So I will update it, and this will be my last resting place 1, because I've already gone in here. And this is dot, since this is dot, so I'll not do anything. And this is stone, so my last resting is whenever I meet stone, it will be updated. So 0 1 2 3, so suppose 3, this is my last resting place, and this is empty, and this is my stone, so stone will go to last resting place. Oh, so this is stone. So if I ever meet a stone, then my last resting place would be actually this one, not stone. Whatever is empty after I get a stone, that should be my last resting place. Yeah. And this is as, so it will go on my last resting place here, and then this will be my dot again, and this stone will also go to last resting place. Okay, so what is the algorithm then? How to find the last resting place? So last resting place will keep on updating once I go from one place to another place, you know. So how to update the last resting place, that is the thing. So suppose so the last resting place is always a ground in the beginning. So if this is, actually this is column 0, right? This starts from 0 and this is the end, right? So it should always be n in the beginning. It should always be the bottom of the box in the beginning, which is equal to, since it will be m times n, and then if I rotate it, it will be n times m. So what is the column's length there? N is the number of rows. Yeah, so n, bottom of the box means n minus 1. So n minus 1 is the bottom index, you know. Yeah, m times n times n. So n, how many rows are there? that -1 is the bottom index, right? So this will be my bottom index in the beginning, and then I will go from n-1 to top to 0. Okay, so when I'm traversing, so this will be my last resting place. When I'm traversing and I find that, okay, in the beginning only there is a stone. Okay, so if I if item at index I it's a stone, or if it is a 20 minutes is already gone. Yeah, if it is a stone or obstacle, then last resting place will be I-1. Okay, yeah, it will go up. And the next time, if it is still a stone or obstacle, then we will go up. Okay, and so what should I do? I think that instead of this, it is better if I do, if item at I is a stone, then what should I do? If item in the is an obstacle, I think this is the better way to write it. Then what should I do? You know, and if item at I is an empty, then what should I do? I think this would be my better logic. So if item at I is a stone, then I should just keep that stone in the last resting place, right? So suppose if this is the item at I, if this is a stone, then my last resting place will be this one. So I'll just keep my cell at last resting place will be equal to the stone, you know, if it is a stone, and then since it will drop, so cell at I will be equal to empty, right? So this is what I should do if my last item is a stone. So yeah, so suppose this is dot and this is hash. So this is my last resting place, and if I drop here, then this will be my last resting place. And then I think what I should also do is last resting place should be equal to, I should just move the last resting place, because since that my last resting place will be replaced by a stone, so another stone, if it drops, it can only drop to the position above that, right? So this will be my formula if it is a stone. So suppose it dropped here, so this is my last resting place, and suppose it dropped here as well, and suppose this is the last resting place and this is only the one, right? Then it means it will be dash and cell I will be empty. So I think that what I can do is, if item at I is a stone, and I should also see, and if cell at last resting place, if it is empty, then only I should drop. Otherwise I can just if it is not empty, then I can just go upwards, you know. Yeah. And if item at I is an obstacle, then I will just, the last resting place will be I-1. And if item at I is empty, then I should just do, what should I do? then my last resting place will be I. Or no, what should I do? I should not do anything, right? I should just do last resting place is equal to, no, yeah, if it is empty then I should not do anything. If it is empty then what can I do? I cannot do anything. Just continue. Right, so is this fine or not? Is this algorithm? Oh, yeah, I think it is fine. So in the cell, in the column, if it is empty, then I'm just going up. Yeah, I'm just going up, and if it is an obstacle, then I will say set last resting place to above, and if it is a stone, then then I will determine if it will fall or not. So if I know that I'll determine if it will fall or not only if I know that last resting place is an empty, But if it does not fall, then I don't have to do anything. I'll just have to go up, continue until up. Yeah, I think this would work. There must be some. So this is a place where should I think of edge case or should I start coding? I should think of edge case, I think. So let's look at this logic again. Yeah, so if it is so if everything is empty and this is the last resting place, the stone will drop there. Stone will drop there and that cell will be empty because it will drop and it will go up stairs. Yeah, it will go up. Cell minus cell is equal to empty. Yeah, and but if that suppose if this is the case, right? So last resting place will be 4 here. It is 4, and yeah, actually this is 4, and since it is not empty, it will not do anything. So this will also not do anything. This will also not do anything. And suppose if this is empty, okay, and this is empty, and suppose if I find this, then where will it drop? What I think is yeah, this I did not consider this case because see, this is has and has. I think what I should do is if this is empty, then it should drop, right? Dropping means this. But if it is not empty, then it's still so if I get a stone and I know that last place is not empty, yeah, I think it should be last resting place should be I minus 1 in this condition. Yeah. So since it cannot drop, so even if the stone drops, then wherever the position the stone drops, the last resting place will be above that, right? So even if the stone cannot drop, then it will be I minus 1 only last resting place. Yeah. If it is an obstacle, then it will be I minus 1. Yeah, I think this would work now. And if it is empty, then I'll just go up and look at. Oh my god, why did I take such a long time to do this? Oof. Should I think about edge case more? Should I think about this edge case more and see if this algorithm is faulty? I don't know, like I've already taken such a long time and I'm already disappointed that I took such a long time. I'm thinking about why did I take such a long time. Was it not straightforward? Like my last resting place will always be, if it is empty, obviously I don't have to do anything, right? But if it is stone, then it will drop to the last resting place. And if I when I'm stepping above, whenever I get a obstacle, then my last resting place will be above that obstacle. Yeah, so these are so simple. Why did I take such long time? I don't know. Let's look at the what coding. Let's look at coding. Yeah, so I just want to go through this again. So what I did is so my first resting place will be the ground, and if I find that if I find any empty cell while going up, okay, I'll just start from the ground. So I'll just start from the ground, and if I go up, if I find a stone, then it will drop to the last ground, you know. It will just be like a ground, you know. This is actually, I can just say that this is like a ground. Last resting place, or you know, last ground. Right, so this will be my last ground will be the top in the beginning. And if it is empty, then I'll just go up until I reach a stone, or until I reach an obstacle. So if it is a stone, then um, yeah, if it is a stone, then it will drop to the ground, and my ground will step above, right? And if it is a if it is an obstacle, then also my ground will step above. And if it is a stone, yeah, and if it is a stone, and my ground is empty, you know, because sometimes my ground can be filled, you know, whatever I'm saying. So yeah, actually this is last ground top, you know, because it can only sit in the last ground top. I think this is a better variable, because it cannot land on the ground, right? It should land on the ground's top surface, last ground surface. Yeah, so my surface, so if my last ground surface is empty, then I will land there. But if my last ground surface is still stone, then I cannot land it. I will just have to go up. Okay, okay. So let's look at this now then. So this algorithm will go from bottom to bottom to up, right? So it means I should, because like I said, last row, what will be my first column? My first column will be first. Last row will be my first column, right? So I should start from the, while coding, start from last row to first row. That will be, last row will be first column, and first column, and go on, you know. And also start from last rows, actually last rows end, i.e. place place the bottom values in column first while constructing column. Okay. Okay, so now let's construct column. Okay, so I will start from the last row, right? So so constant m will be equal to box.length, and constant n will be equal to box 0.length, and for so I should start from the last row, right? So last row means or I'll just do them in an okay. So my last row means what does last row mean? Box m minus 1, right? Last row means, because m minus 1, yeah, this is the last row. So I should start from last to first, right? So if it will be I is equal to m minus 1 to I is, it will go from last to first, so it should be greater than or equal to 0, I minus minus. So my last row will be my first column, right? So this is my last row, and then I should start from row's end. So my row's last value row's end means last column of row. It will be, if this is a row, then it will be n minus 1, right? Because that is the last because that is the last point. Row's end, row and row's end, 0 to n minus 1, yeah, because that is the n, right? So now since I'll go from row's end to up, right? So I'll construct a let matrix, let new box is equal to new array of length n in the beginning, and then for let I is equal to 0, I is less than new box dot length. I'm just constructing I plus plus. I'm just constructing new box I is equal to new array. I'm constructing a two-dimensional array of m, right? So first of all, I constructed length of n, and then inserted m here. I can say that I can fill with 0 in the beginning, or no, I don't have to fill with anything, isn't it? Yeah. And then also I can say that this last ground surface, oh no, so last ground surface for anything, I think I should go from top to bottom, right? Item at I is a stone, so I should go from top to bottom. So box I n minus 1, so n minus 1 will be my current. Let current let current index is equal to n minus 1, right? So I should go until n minus 1 is greater than or equal to 0. Okay, until this I need to go, otherwise, and yeah, so it means that I'm going from bottom to top. Okay, and then I should construct new box. So new box will be equal to I think this, and current index will be, because my, so this last row will be, this last row to first row, so last row will be my first column, right? So so this box I n minus 1 should be my first columns last row value. So how can I say this is my first columns last row value here? So first row, first column, oh no, last row value means I, no, yeah, this will be last row value. Yeah, I'm just trying to figure out how to assign this. How to assign this? Oh my god. Seriously, 20 minutes has also gone? Oh my god. Oh my god, this is a time where this question should not be this hard, but why am I making like so? So my last column. So here, what's happening is I should think quickly. I'm thinking so slowly. So my first row, last row. So my last row will be my first column, right? So last row's end will be my how will I don't know, I don't understand, like how am I going to do this for loop? So let's see. So this is I is equal to m minus 1, right? So this is my last row, it will be my first column. So m minus 1 means m minus 1 will become my first column. I think that it would be easier for me if I know. I was thinking that if I first rotate and then after rotating just drop, because here I'm trying to rotate and drop at the same time, but I can do that, I think. Or if it will be easier for me, then I can first rotate and then drop. It will be same time complexity. Yeah. Okay, then let's think about rotating first. Okay. So there, for dropping instance I will go again, but for how will I rotate box? First of all, I need to think about that. So for rotating box, this is the logic, right? My last row will be my first column, and my first last row to first row, last row will be first column, and so on. So how will I convert my last row to first column? So my last row will be first column. So my last row will be first column. If so, my last row means m minus 1, right? So m minus 1 will be m minus 1 m minus 1 x will be first column. So first column means 0. So if it is m minus 1, then it will all be 0, because this is the first column. Whatever, no matter what, the row will keep on increasing, decreasing, but this will be a first column, m minus 1. Is there a way to think about this? So my last row will be my first column. This is what it means, right? First row is my first column, and so suppose m is equal to suppose m is equal to 3 and n is equal to 2. Okay, then suppose m minus 1 is equal to 3 and n minus 1 is equal to 2. Okay, 2 and then this will be 1, right? So then it means that 2x will be 0. So I will start from the 2x will be 0, 0, right? So last row, so how many columns are there? M is equal to 3, n is equal to 2. So it means there are 3 rows and 2 columns, right? So it means this will go from 3 rows, 2 columns. So I think this will just be this much only. So there will be 2 columns, right? This last row first column, last row second column. So last row first column will be first row, right? So yeah, last row first column will be first row only, and this will be 1 only. So yeah, so last row first column is first row first column, and last row last column is first row last column. First column will be first row, last column will be last row. Yeah, and similarly I can go from like for 2, right? There are 3 rows, isn't it? So it will be 1 again, and it will be 2 now. So this is how I can do. Yeah, this is how I can do. These things are not changing, right? Yeah, this is how I can do actually. So for every loop I can just start from 2 to 0. What am I doing here? 2 is 0. This would have been 0. 2 is 2 1 0, so it will be 1, and this will be 2. Yeah, because first row will be last column. Oh my god, why is this matrix manipulation so tricky? Actually, I don't think this is so tricky, but this is just that this, because just looking at this so many brackets, it just makes my eyes so blurry. Is this right or wrong? Is this following this principle or not? So last row will be first column, first row will be last column, first column will be first row, last column will be last row. So it means last row first column will be whatever the value in last row first column will be in first column first row, right? Last row first column will be first row first column, yeah. And so if it moved here, then and value in first row last column, first row last column will be last row last column. Yes, so yeah, actually to construct any array I should just think from first to last, right? So this will be my first row first column first row, and this will be my first column first row, and this will be my last row last column. I think this is it, right? First row will be last row, first row will be first last column, and last column will be last row. Yeah, I think this is it. So to construct my I was trying to write first column first row here. So to construct my first column first row first column, I need to look at the value for last row and first column. And to construct my last row last column, I need to look value for first row last column. So yeah, actually instead of this, what I can do is for I is equal to 0, I is less than something, I is less than n, I plus plus, because my column had changed, right? So and for j is equal to 0, j is less than m, j plus plus. Yeah, instead of thinking so minutely, I just thought about my first and last. Okay, first row first column, last row last column. So I'll just look through that now. So this will give me my new box ij. So yeah, so first of all I will construct my first row, and then second row. First row I will construct, second row, third row, fourth row. Okay, so how will I construct my first row? So what is my first row first column here? First row, my first column is last row first column, right? So it means it will be box last row first column. So last row first column means I, j, I think. Isn't it? Oh my god, did I think so much for just for this? Yeah, so this is my first row, this will be my j last row first row first column, right? So this is last row and first column. Yeah, so this will be my last row because j no, this will be last row and first column will be 0 only. Okay, So my first row, because I'm constructing my first row in the beginning, so my first row will be last column. So so since here when I is equal to 0, so I'm trying to construct a box for I is equal to 0, right? Here I'm trying to construct a first row here. So my first row will always be in the last column value, box last column value. Yeah, I think I need to find something like last column value means if I is equal to 0, then j will be, yeah, I just need to construct some expression here, you know. So I is equal to 0, then what should j be? I can just say this value in so box last row last column will be equal to first row first column 0 0, first row last column, last column means n, right? Isn't this correct? So for new box 0 0, it means value in last row first column. So this is the last row and first column of the box, and for this one last row last column will be equal to this one box is first row and last column. Yeah, I think so. So how can I make it here? How can I change this as expression? So for I, if it is not, if I is always 0 and j, if it keeps on changing, then I think this would be I only. And this would change. This would be m minus 1 minus j. Yeah, I think so. I think this is right. I think this would work. This formula for rotating the box. Yes, this would rotate the box actually. Because this row is becoming column first. Because this row, whatever the column here it is, column is becoming row here, right? Whatever the column is here, that is becoming row, and whatever the row is here, the last row is becoming first column here, because it is m minus 1 minus j. So if j is 0, then it will be m minus 1. If j is 0, yeah, it will be m minus 1. And if j is the end, last row, then it will be 0. Just all verifying this logic. New box ij is equal to box n minus 1 minus ji. Okay, looks good to me. Now after this, now let's drop the stones. So dropping the stones, it means I should just follow this logic. So this is the logic that is I should follow for dropping stones. Yeah, so for dropping stones, I can just go from one column to another column, right? From first column to last column. So while j is equal to 0, j is less than column means, so it is m times m, right? So n times m, so m will become my column, j plus plus, and for since I'm going from first column to last, and I need to go from ground to up. So going from ground to up means n, right? So it will be I will be n minus 1, and I is greater than or equal to 0, I minus minus. Okay, yeah, so this will be my first 0 and minus 1. It will be my first column and last row, yeah. What I think is my like weakness right now is I just try to visualize every single detail, but sometimes I can just leave it to mathematical calculation like this. See, I just left it to mathematical calculation and it works. But here I was trying to visualize it and everything. Yeah. So new box ij, it will be equal to right, I did right. So if it is equal to if it is a stone, yeah, if it is empty, then I should not do anything, continue. But if it is a current item empty, if current item is equal to empty, then if if current item is equal to stone, then I should do something. And if current item if it is equal to obstacle, then I should do something, right? So if it is an stone, then what should I do? If it is an obstacle, then what should I do? I should not do anything. Oh yeah. I should do something. So for everything, I should actually for every column, I should just say that let ground surface light, let ground surface should be n minus 1 in the beginning, right? Because this is the ground surface. So my ground surface will be equal to I minus 1 in that case, right? It will go up. And if new box, my last ground surface in the same column, if it is equal to if it is not equal to if it is equal to empty, if it is empty, then I should do something. But if it is not empty, then yeah, even if it is empty or not empty, I should always say that last ground surface is I minus 1, because they both are the obstacle. But if it is empty, then my new last ground surface J will be equal to stone, and this current ij will be equal to empty. Yeah, this is it. And at last I should return new box. This is it, right? So I think I did everything here. For dropping stones, I'll go from n minus 1 to 0. I went from n minus 1 to 0. And if stone is empty, then stone empty. If it is empty, then I did stone and empty. I minus 1, continue. Yeah, looks good to me. So this was a typo. Wow, 2 worked. This only did not work. This also worked. This also worked. This did not work. Let's see how many test cases will pass. Oh wow, 929 test cases passed. This is good, at least. Okay, so let's do console log, okay, to see if it is turning right or wrong way. Box, new box. So this is my box and this is my new box. So I am always confused. My last row should be my first column. Is this my first column or has dot. So this has asterisk dot. This is has asterisk dot. Okay, this is fine. So rotating looks good to me. Now let's see what is happening after I'm trying to drop the stones. Okay, so here is dot, this has it goes down, and this will become empty, and this will be has again. This is empty again. Here. What is happening here? So this is dot, right? And then this has to drop to dot. Yeah, it dropped. I think that I should take some rest. I'm nearly there. I think the biggest takeaway until now is that I was trying to visualize each and everything, but I need to stop thinking everything so precisely. I should keep I should talk about, I should just think about mathematical terms also. See, this was so easy, but I was doing all this. I was trying to do everything like step by step, just by visualizing, but no. See, this is so easy, like I can just go from top to bottom. So there is a smart way of doing things instead of trying to dig by so well. I can just run a tractor like this instead of trying to run every single mod by my own hand like this. uh, okay, so here what's wrong? mm, I'm thinking about what I just meant by saying so well in tractor. What I meant was, yeah, I don't have to think every single detail, I just have to think about my goal, where I want to reach, and for there, what is the best way to reach there, what is the best way to do that. I have to be goal oriented first, where I want to reach, and then the solution will follow. Because right now I'm not thinking about the goal, I'm just going, and trying to dig everything. I don't have to dig everything. If I know what I need to do, other things, it can be mathematical formula, maybe something can come up like this. So yeah, I need to be more aware of that. Okay, so here what's happening here? So has, what is the time? It is already 9. So has, so this is has, right? So it will come down, and this will be has, and this will be empty, and this will be my last resting place. This is empty, and okay, let's try to run through my code. Okay, for this one. So for this one, in the beginning it is empty, so it will be has, and this will be empty. This will be has, this will be empty. This will be has, and this will be, yeah, I'm digging here again. But first let's try to find the goal. Or no, let's dig. So this is has. When I say let's first try to find the goal, I say let's first try to discover the problem. If I know the problem, then maybe the solution will be very short. But without thinking about the problem first, what is the problem? I'm just going through everywhere. And right now also I'm doing the same thing, without looking at the actual problem, looking at what is wrong. I'm just looking at everything. But let's do that. Yeah, has dot, this will be dot, and this will be dot again, and this is has. So it will come here, and then this will be dot, and this will be my last resting place. So 1 2 3 4, 1 2 3 4. So this will be has again, and this will be dot again, this will be has, and this is has. So it will be dot, and it will go here. Okay, so this is my first column, dot dot has. This is not correct. My first column is dot dot has. But oh wow, it is returning different thing. Has dot has, which is wrong, absolutely wrong. I think what am I doing mistake here? So I'm dropping these stones. I'm going from j is equal to m to n, right? So my new box, it will be n times m, right? N is row and m is column, isn't it? So I'm going to through column first. I'm going from j0 to m, and I'm going from n minus 1 to j to 0. This looks good to me. So my current item will be ij, right? My current item will be ij, right? Because this is my column and this is my row. Yeah, so it will be ij. J will always be 0. J will always be from 0 to m minus 1 because m is the column. And if it is empty, then continue. If it is hash, then if my last ground surface, if n minus 1 is empty, then why is this not working? It should have worked, right? So here, so this will be my this is 1 2 3 4 5 6 6 times 3, so this will be my 3 times 6, 3 times 6, 3 times 6, so j will be 0 and 6 column, j will be 0 and row will be start from n minus 1, which is 2, so it will be 2 1 and 0. So in the beginning it will be 2 0 and the last one, and if it is dot, then I will continue. What does continue do? Continue will, it should just continue this one, right? Yeah, else if current item is hash, right? So this will be my hash now, and this will be my hash, and this will be my dot now. This will be my hash and this will be my dot now, right? Yeah, n minus 1 g will be hash and this will be dot. And last ground surface will be I minus 1. Whatever is the current index, that will be minus 1. So my last ground surface will be now this. And this will continue, and it will go here, hash. So hash will be again it will be replaced. And this will be my current ground surface, and this will be replaced. And this will be my current ground surface, and this will be replaced. So yeah, it should happen like that. Then why is it not updating? What am I doing wrong here? New box, it should have updated, right? New box, this should have been updated. it is returning something like this. Has dot has. Why is it returning something like this? Why is it returning something like this? So this has goes here and this will dot. This is fine until now, but why is this has going here? This two has, why is it not dropping here? That is my question. I think there is some like this one is not working properly. I think j is 0 and j is less than n, j plus plus this last ground surface will be equal to n minus 1. So current item new box will be ij. Is it not going inside here? If current item is equal to has, then if it is dot, like is this not working or what is happening here? I don't understand. And my algorithm is correct. What we can do is we can just do console.log and for every I can just say what is the last ground surface. Okay, maybe j as well. So if it is 4 0 last ground surface is 3 now, because yeah, this is fine, this has dropped. Wow, interesting. So this is fine, right? So because it was fine, right? 5 5. Why is it doing it? 5 5 3 3 2 2. Why is it logging 2 times? Why is it logging 5 5 5 5 2 times? I think it is because yeah, I think it is because it was dot. Yeah, so let's see. So 5 dot, so it is skipped. So now last round will be 0 1 2 3 4 5 only. So I discovered 5 hash. So now it should do this, and ground will be 4. So this will be hash and this will be dot, right? But why is my last ground service 3? It should be 0 1 2 3 4. It should be 4 only. It should not be 3. Why is it decreasing? How did it decrease? This is 5 dot and this is 5 hash. It is just I minus 1, right? Zero, 1, 2, 3, 4, 5. What is happening here? I don't understand. So 0, 1, 2, 3, 4, 5. So in 5 I found has say what's, yeah, I found has in position 5. 0, 1, 2, 3, 4, 5. Oh my god. Okay, so first of all, last ground surface is 5 and last ground surface is 5 and current item is hash. Even while logging I should log so that my brain will intuitively understand. So last ground surface is 5, last ground surface is 5 and last ground surface is, since we found hash, so last ground surface moved to 4. So this is my last ground surface. No, so my last ground surface is, how did it reach from 5 to 3? That's what I don't understand. So see, in the beginning it is 5, right? In the beginning last ground surface is 5 and the current item is hash. So if the current item is hash, then I should also do this. So in this position 4 I found hash, right? So it replaced hash and dot. So 0 1 2 3 4 5. So 4 is replaced by dot now, and hash is replaced by, oh yeah, I should have done that actually. I was right in the beginning only. So it should be I minus 1 in this case, but if this is the case, then it should be last ground surface minus 1. Okay, it got accepted. Yay! So the only mistake I was doing was this one. I did not consider this. Actually, when I was writing my algorithm, I wrote that, in the beginning, I wrote that last ground surface would be last ground surface minus 1. Then again, I changed that. So I think that when we keep on thinking, when we think about so many things, sometimes we can lose track of our previous thought, because when I wrote that last ground surface is equal to last ground surface minus 1, I also shared that is the case. But then again I came to another thought, and then my previous conclusion, it disappeared. So I should not let that happen. So I think that I should have, instead of just writing last ground is equal to last ground minus 1, I should have written some more descriptive thing, so that when I changed that code, I would have known why I came to that conclusion before. It is just like sometimes, like, it happens like you write a code, and after 1 year when you look back, you don't understand and you change it, right, according to what you think. But you should have some comment or some description there, so that you will know why you did what you did. Yeah, so this was the biggest thing, because obviously if it is cropping, then it should not just be I minus 1, right? It should be last ground surface minus 1. Let's look at the solution. Row by row, brute force. Oh my god, this is a brute force solution. I did a brute force solution, right? I rotated the grid, first rotating the grid and then applying the gravity effect. What is the better solution then? Row by row optimized. So it's important to consider the lower bound of the algorithm's complexity. In this case, we feel investigate whether we can return of our previous approach to low. It turns out we can achieve this by third inner loop is instead of checking each empty cell to see if stone can land, we can maintain a pointer to the lowest empty cell. Oh yeah, that's what I did. I maintained the pointer. Oh wow, it means that I did do this. If it is has, then do this. If it is as, then it is just this only. I don't even need this, I don't even have to do that continue etc thing. Combined rotation and gravity. So this is m times n, yeah. This is also m times n. Yeah, actually this is what I was trying to do in the beginning. I wanted to do both combining rotation and gravity operation at the same time. I wanted to do that right here, But then again, like, I was very stuck, and then I thought, okay, I will do it separately. Yeah, this was what I was trying to do in the beginning. Okay guys, thank you so much for watching. I think I'm partially satisfied with this problem by looking at the editorial at last, because I did optimization and I thought about the best solution in the beginning. But I think while execution I need to improve it. I can improve it by, I think, two things. Main thing that I did wrong here. So I'll start from the last. So my second point is, what is my second point? Yeah, second point is, while I write the pseudocode, I should write it more descriptively, so that I will not forget what I thought before, what I concluded before, so that I'll not overwrite that again after I think another thing, So that is important. Write descriptive pseudocode so that I will not forget my previous conclusion. That's second point. And the first and most important point is, like I said in the video only, I was very I was trying to dig into everything by myself, but instead of that, I instead of that, I just can think very quickly, just mathematically, think mathematically instead of thinking everything visually, precisely. Just see what is the problem and just try to find a direct solution to that problem instead of not looking at the problem first and just digging, just trying to do everything. Okay. 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 What are they doing? Reverse function. Where is the reverse function? This is what I did to rotate box 90 degrees, and this is what they did. What is transpose of the matrix? I forgot. I read that in school. This is the thing that they did to rotate, but I did this. Anyway, I think my solution is better. But yeah. Okay. Yeah, thank you everyone. Bye bye. Hope you have a great night and day, depending on what time of the day you are watching this video and what region of the world are you in. Bye bye. I will come back again after 2 or 3 minutes with another LeetCode.